Right, welcome to week 3 on chemical sciences. This week we're doing an overview of the ACS Chemical Sciences Strand. Now, some of you will be relatively familiar with the Strand, so you will find this week's going probably a little bit of a rehearsal, a little bit of revision, but that's really important to know that, and still engage in some of the activities we've listed for you online. And one of the reasons there, of course, is thinking scientifically, practicing scientifically, and of course acting and speaking scientifically. We're focusing very much in this unit on the language and the meta-language and the meta-narrative of science. And the chemical sciences is one of those areas where we do sometimes tend to feel intimidated. And yet the aim here, of course, is to show that chemical science is really just as natural and just as inquisitive and as rich as any other of the sciences that we actually think we prefer. So just asking you to suspend your disbelief. And the activity this week actually asks you to do at least one science application and investigation, and also we roll out your chemical maze application for the first time this week. So and again, as a form of science, it's a really good one for developing the language side of science, also the sustainability science, and also the personal side. So in how you are connected as a tool of science inquiry yourself, what impact toxic chemicals can have on you as an object of your own study. So it really, we're trying to push you closer to a framework here to enable you to use common sense chemical sciences in normal and investigations and in everyday applications to yourself and to your world. And that's essentially what this unit is all about. So when we look at chemical sciences, how hard is it? Well, this unit actually comes from the Science by Doing people again, and they come up with some great resources, and it's something every kid knows: rock, paper, scissors. I mean, it's just a brilliant activity. Of course, the science understanding here is materials. And you can see it sort of rolls in this little introductory task. Can you imagine starting a unit? Here's the first of the 5 E's: engagement. You're right up there on the engagement scale. Let's have a game of rock, paper, scissors. Most of the kids already know it. What are the aims? Obviously, to get kids into it. The aim is really to start tackling misconceptions. And down the right-hand side of the screen here, we've got the outcomes. Look at some of the properties of materials, because that's really what this game is all about. What is the properties of a rock? Look at the 3 pictures here below. Which combination would win and why? Okay, and again, if we can identify the whys, then we're talking about properties. And the message to the kids here is, okay, let's have science in your language. Let's begin from where you are. Describe how the properties of materials relate to how they can be used. And again, we point out down here, this is a common misconception. A lot of kids don't actually realise how the properties of materials can open themselves up to different use. Too often, we focus on things like colour and shape. And unfortunately, our notion of science and science applicability and scientific analysis and evaluation is really limited to what we can see, these physical properties, rather than breaking things down to their molecular levels where the science curriculum truly operates. And the third lesson outcome here is describe the importance of working safely in the science laboratory. And of course, you can drill all of that into this particular lesson. So it's a great little starting routine, a great little engagement strategy. And if you're doing something on materials, it's a topic that goes right across many of the curriculum years. It's a great way to get your students in. So what are we talking about this week? We are talking about the ACS. Now, this diagram here represents the ACS quite well. It takes us through our learning areas: mathematics, science, English, history, geography, what we call HAS, the arts, languages, health and physical education, and technologies. It shows that the ACS has 3 curriculum priorities, and the one probably most relevant to what we're doing now in chemical sciences is sustainability and the physical sciences. Aboriginal and Asian engagement and Aboriginal perspectives are quite important here. However, the strongest one, the biggest link for us here in our science investigations and in science inquiry, is going to very much be around sustainability. The general capabilities, there are 7 of them, and there they are. And we can see here that highlighted in red are the strong links of this particular of science and this particular strand of science with the curriculum. So English, we can see the language component, mathematics, history, geography, sustainability, critical and creative reasoning, and personal and social competence. So these are the things that we're trying to drill by looking at chemical sciences. And the chemical physical properties of substances are determined by their structure at an atomic level, and substances change and new substances produced by rearranging atoms through atomic interactions and energy transfer. So energy transfer is a big part of this one as well. So we can see here that this is really quite a rich and quite an interesting strand to be studying. We can see that we've got our three interrelated strands. Our science understanding is chemical sciences, and what they're about here, the substrands, here they are. Okay? Interesting stuff. So what are we supposed to look at this week? What are we supposed to learn? Well, again, we've got our transitive verbs: locate, describe, and explain. Locate where the chemical understandings in the ACS are. Describe the links between those and the cross-curriculum priority of sustainability, which is really the leverage, is what we call the curriculum leverage and warrant that we have here. And explain why where the ACS tends to focus on the general capabilities. Now, this will happen, and it will be made explicit to you in some of the curriculum resources and examples I'm going to point out to you in this lecture, this online lecture now, this content lecture. So the whole purpose here is I'm going to point out to you two resources you may already know. Primary connections. I must admit, up till now I focused very much on science by doing. The reason being is because science by doing people, Dennis Goodrum is really, really strong on the inquiry model. And they're also really, really strong on the 5Es model. What we're going to discover today is that primary connections actually is also, the 5Es model is embedded in primary connections. It's its principal mode of inquiry teaching. So we're going to see a lot of common ground here. And what we're doing is we're opening up, even though science by doing specialises in 7 to 10, okay, primary connections goes all the way from F right through to 10. So what we're doing now is opening up that umbrella of resources. So the key terms we need to look at this week: chemical science, the composition, structure, properties, and changes of matter. That's what we're looking at. Sustainability, okay, is our cross-curricular link. Futures-oriented, focusing on protecting environments and creating a more ecological and socially just world through informed action. Notice that, some rich connections there, informed action. So there's a cultural component to this too. So again, in the general capabilities, we will see students develop capacity and capability when they apply knowledge and skills confidently, effectively and appropriately in complex and changing circumstances. So this can be culture. This can be technology. This can be all of these other generic capabilities. Now, if you haven't come across the generic capabilities yet, or the general capabilities, ACARA has a separate set of pages on them. There are 7 of them, and we'll come to them later in this lecture, so you'll know what you're looking for when you see them. Navigating the ACS, the chemical sciences, I'm going to introduce you to this particular site, SCoodle. Now, SCoodle is worth its weight in gold. Primarily because it takes you to primary connections, and it does so in a way that's completely navigable and completely teacher-centered. So if you're not a member of SCoodle, please have a close look at this and you'll understand why you need to be. Let's have a look, please. I've just pre-recorded a video I'll play for you. Welcome to SCoodle. Now, as you can see up here in our location bar, it is www.scoodle.edu.au. Now, if you are not a member, I urge you quickly to join. It is free, and it actually links you very, very explicitly to ACARA, and from ACARA, of course, comes the primary connections links. Now, you will notice that primary connections is embedded in the 5Es model, so everything you do is inquiry related, and it's an inquiry teacher's paradise in here. So if you haven't joined SCoodle, it's free, and it can be done instantly, and it brings you to this wonderful resource. How wonderful is it? Well, make your own judgment, because we can browse by the Australian curriculum. Now we can see here that every curriculum item is covered from foundation year to year 10. But we're really not interested in every curriculum item. We're only interested in the main curriculum item here, which is of course science. Now when we click on the science link, we can see that it gives us vertical as well as horizontal navigation. Now we can see here that ACARA are the people behind this particular resource, and the aim of course is to make science teaching explicit and relevant, and of course to give you ideas and resources. So we're going to look at the foundation year, and for those students in this course, in this unit of study, who've been working by science by doing, I mean, the reason why I promoted that first is because it actually does extend a whole range of pedagogical approaches to inquiry-based learning. This particular site, SCoodle, also does this. It does it brilliantly as well, particularly through primary connections. Let's have a look at how much so. I mean, week 3 we're focusing on chemical sciences. Let's have a look at the foundation year, what chemical resources are available. And it brings up one particular unit of study, and it's linked to the standard 003, and we can actually see the resources for ourselves and make our own critical judgments about how, what, when and where we may use them. Nice point is we get the curriculum descriptions, very handy for your assignment, part B. We get the curriculum elaborations, very, very handy also for your assignment, part number B. And we also get the results. Now you can see that we've actually got the standard identified, and we can see we've got 4 direct matches to it. Only one of these is uniquely for the foundation year, however. If we have a look at the remaining matches, we can see that they come up for foundations up to 4. You will always also see that beside each of the units is a little icon. And the iconoclastic world of web navigation, these are actually artifacts which tell us what to do. So we can see here this is a little camera, and if we go back we can see this resource actually contains video. And there's a wonderful character in here called Dirt Girl. If you haven't met Dirt Girl yet, you just got to meet her. She's a heap of fun. The kids love her, and I really, really encourage you to get in and explore. So you can look at the details of the resource, okay? And the details actually give you a little rundown, a comprehensive rundown, and a brief summary and description. And it gives you the 3 strands that are covered, and it also gives you the science understanding, which in this case, of course, is described on the previous page. We can go here and actually view the resource ourselves. And when you open up the resource, there it is. It's online version. So this is an interactive online version, and we can see here that it's a complete unit based on chemical sciences. And if you don't want to stay online and interact with it, you actually have the option of downloading it as a PDF. As a PDF file, it can be very, very useful, and it can be permanently on your desktop, so you can open your iPad, or you can open your desktop at any particular point in time and just reacquaint yourself with what you're doing. But when we click on the module, it brings up the unit for us. Very clear focus, foundation year. It's the primary connections program. You can read about that. You can look at the unit at a glance. You can look at how it aligns with the Australian curriculum. You can look at the strong literacy focus embedded within primary connections. And you can look at the teacher background information, which of course links and talks about the 5Es model. There's an introduction to these materials, and of course, and then come the actual lessons themselves. And of course, this is all about the chemical sciences. And the one that we're going to focus on, of course, is making sense of materials. You can choose all of these. The little maps exercise is brilliant. A little 2-lesson learning sequence, and in that learning sequence, kids get to predict what they're going to see in their playground, and then the second part of the lesson is to actually make it. So these are very, very valuable, very, very, very kinesthetic, very, very grounded units of study. Let's look at making sense of materials. And we can see how it's structured. It's lesson 4 in a sequence of chemical science lessons, which may go over a whole term. You may stretch over a year. You may look at chemistry one term, biology the next, earth sciences the next, space sciences the next. Either way, primary connections is going to give you a very, very detailed unit of study. Look at the first one, making books. Okay, and this actually talks about science journals, representing observations, discussing why people select materials. And session 2 is silly stories, which is an optional session. It then takes you through the lesson focus for each. Your lesson outcomes, of course, literacy is mapped onto science at the foundation year. Obviously, it's a very, very critical part of the foundation year. Some important teacher background, and this gives you the information that you need to find out and research. Now, preparation is everything in teaching chemical sciences, because in our online discussion last week in the Zoom collaborative, a couple of people actually confessed that science freaks them out. They don't, as teachers, it's not a comfort zone. That's brilliant, because that's a spark, and a spark lights a fire, and the fire is inquiry. So you should be captured in that blaze too. You should be lighting up, and that should be a cue to you that you should read this background information, because the key concepts are all going to be in here. Arm yourself with an understanding of them, and the lesson will flow. You'll be able to get the students to work with those concepts very, very well. the student conceptions, okay, and here's the area where we may be able to rise and focus on our misconceptions. Young students have a very limited understanding of plastic and how it can be used. They may not associate plastic with clothing. We may not associate bamboo with clothing. All of these are new innovations, new scientific applications, and it takes you through each of the sessions. Okay, you can see making books session number 1, and we can scroll through that. I'll let you scroll through it on your own time. But please, I do thoroughly recommend this to you. It's very, very important. The reason being, you can see here really, really positive models for assessment task 1, part B. You need to come up with your own lesson sequence. You need to do it using the 5E inquiry model, and as you can see, each of these lessons actually comes with a hyphenated link. You know, this is the engagement stage, and it usually tells you that, oh sorry, here we are on the explain stage. This lesson comes in at the explain stage. So some of the pedagogy associated with this lesson will be the ones you use when you're dealing with the explain E in your model. Please, if you don't have a SCoodle account, grab one. Once you're in there, make sure you explore primary connections. It gives you all the links, helps you set up the structure and the rationale, and helps you learn about the structure of the Australian Curriculum Science, Chemical Sciences Framework. And let's not stop there. I mean, why not focus also on the Chemical Sciences assignment number 2, assessment task number 2, because there you're actually doing a review of 2 primary connections units. And so I've put some online in the subject site for you, but hopefully you'll also be able to choose whether you use these resources to actually do that exploration as well. And next slide. Primary connections, SCoodle and the 5Es. Just to recap some of the points made there and some of the possibilities for you. Primary connections is definitely built around the 5Es inquiry model. You'll see each of the resources and lesson sequences actually speak to the 5Es model. It will be explicit. SCoodle is designed and developed by ACARA, so therefore we can actually trust it's heading in the right direction for us. The ACS is also designed and developed by ACARA, so obviously these 2 resources are going to go hand in hand. It's focused on the F to 10, that is SCoodle. Science by Doing is focused on the 7 to 10. But when we put them together, there's complete overlap in each approach, and the 5Es model underpins both of them. So when we look at this, we've actually got together this primary connections and Science by Doing are a comprehensive F to 10 curriculum resource. There should be no lack of guidance, there should be no lack of model, there should be no lack of curriculum connection when it comes to us doing our own assessment, because we have some excellent standards to follow here. Now this little diagram is really important. It's a structure of the Australian Curriculum Science. We have here our understandings as we go around, and we have our strands in the centre. So we've got science at our core. It's broken into 3 strands which run simultaneously together. Notice they're in a wheel, a motion wheel there. And the ones we're looking at are scale and measurement, patterns of order and organisation, form and function, stability and change, systems, and matter and energy. Okay, so here is the scope of our investigations. Another resource I'd like to introduce you to is ABC Splash. Now, the reason, again, I'm looking at this is because you're looking for resources and items and guidelines as to how you can actually use some of these things in your own assignment task number 2. Let's have a look at ABC Flash. Interesting to see how many, and we'll talk about it in the Zoom Collaborative this week, how many of you are actually using it at this point in your time. Right, welcome to the Splash site. This is Splash ABC. And as you can see, it again is another resource site for teachers in general and for teachers of science. So what we're going to do actually is go in here and have a look for, as you can see, find resources, great stuff for teachers, play games and explore for kids, and join in, make, share and learn. So there's obviously resources you can set up here for your class as well. More, I'll leave that up to you to discuss because it may or may not fit into your lesson sequence. But let's have a look at the resources that are available here. So it brings you obviously to a really useful Splash page. On that Splash page we've got all of the Australian curriculum areas, we've got all of the relevant years from Foundation to 10, and we've got a whole range of media. Now these multimedia resources are really, really rich. For instance, we can look at video resources only if we want to send students direct to them. We've got a thing called topics, which is a general area, and we're going to go in there in a moment because they actually got a topic called experiments, and in experiments are a range of experiments, of a chemical nature, obviously, that we can do as part of our classrooms. Digibooks are absolutely fantastic. Let's pop in there and have a look at the Digibooks. And as you can see, we may, for instance, pick a Year 3 Digibooks and see what's available in the science area. And we can have a look and we see there are 2 Digibooks available there. And these resources are just beautiful. We go back to the Year 2 level, okay, and we include Year 1, 2 and 3. So there's one particularly there for Foundations in Year 1. Now this is a beautiful Digibook, this one, by Don Spencer from Play School. And you can see, very handy here, it tells us we're dealing with animals in the plant and animal cell component of the Australian curriculum. Okay, and we can see that this is designed in a chapter format, and it flicks through the chapter. There's some easy to read text where a teacher, parent, it can also be used for flipping the classroom quite nicely. You can see there, it also has quite very, very rich interactive videos. They're short ones, and they feature people the children know.
This is one of the most amazing creatures in the whole world, and it's only found here in Australia.
Now it goes through 12 chapters of really, really rich resources, and you can certainly use that in different parts of your teaching. Let's go in and have a look at topics. Now we're actually going to look at the experiments topic, and as you can see, it's relevant for science years 1 through to 10. So in here, for instance, it gives you a breakdown of each of the resources available, and we can see what year levels they actually apply. We have the egg experiment, which of course comes with video component. We've got a couple of others here. The elephant's toothpaste experiment sounds interesting, be worth a look. But let's have a look at the egg experiment. And you can see it comes with instruction video, and from there it gives you about a 30-second video, and it tells you a little bit about how to use this and how to conduct the experiment. It's quite instructional. So again, some resources there available for you in the ABC splash page. Use it as much as you can. They are very, very good resources. In the experiments page, you can see that there's a range of resources available to you. Not many of them are for the low end of the curriculum, of course. If we go back into the page here, we can scroll down and we can actually see under topics that there is actually an elements. If we go to another page, we can see animals are renewable energy is one of materials and tools is one of the, of course, the chemical science strands, and water is also in there, and elements and compounds too. As you can see, there is material working in here. So fossil fuels is also forces, part of course the chemical and physical science strands will fit into there. Plenty of resources here for you to look at and use, and if you can, go down to ABC Splash. It is free. The resources are quite useful. In the elements and compounds, there's not very many for the junior high school, if any at all. I think I did find 1 or 2 that go back to about year 2, but really there's not too much in there in the chemical sciences, so it's an area that tends not to be opened up terribly much in the early years, the elements and compounds. For your consideration. Right, so really good resources, and the reason why we're pointing them to you this week is because the topic is chemical sciences, and you are looking for resources that you may use to populate your own learning sequence, and that learning sequence, of course, depending on the misconception that you're actually addressing. So, next slide. When we look at chemical sciences, this week on the subject Moodle, I've actually given you a breakdown there of the chemical sciences across the groups and where we might be able to find the chemical sciences in each of our curriculum statements and elaborations. So when we look at the foundations year, for instance, we can see that objects are made of materials that have observable properties, and we've got the standard 003 there. At level 1, the standard 018. Everyday materials can be physically changed in a variety of ways, and some of the ways we can look at that is predicting and comparing the shapes of objects made from different materials. How they can be physically changed through bending, stretching and twisting. A lot of fun. Exploring how materials such as water, chocolate or Play-Doh can change where warmed or cool. And again, standard 031. Different materials can be combined for particular purposes. We can look at a variety of materials and the ways in which they're used. We can look at mixing materials together, and which different part of everyday objects such as toys and clothes are made from different materials, and identifying materials such as paper that can be changed and remade and recycled into new products, and which brings into, of course, into consideration the whole notion of 3D printing, which is really quite interesting. Moving on through the curriculum, we get to Year 3. That change of state between solid and liquid can be caused by adding or removing heat, Standard 046. And again, we're looking at liquids and solids, how they change in relation to heat and temperature, solid to liquid, and how we can use that for purposes of recycling, for instance, papers and cardboard to papers, and of course predicting the effect of heat on different materials. And we go on through each levels of the curriculum. Level 5, Year 5, solids, liquids and gases have different observable properties and behave in different ways. Standards 077. And we can see here, for instance, balloons and bubbles come into it. Solids, liquids, gases, what happens when you heat them and when they cool? Okay, and this really asks the whole question here. I had a student inquiring on the forum this week about dissolving liquids. What happens to things when they dissolve? Do they disappear? Again, you can see it fitting very much here into this particular standard. At Year 6 level, changes to materials can be reversible or irreversible. Instantly, you can make a particular substance disappear and then you can make it reappear through scientific processes. So it's really interesting to explore reversibility changes and how that impacts on materials also. And again, this was a matter raised by Lauren in the Zoom collaborative last week. So really, really interesting topic. An interesting investigation to actually conduct a dissolution experiment and then to actually reverse it, which is really, creates a little bit of wonder and awe there, a new dimension. When we go up through the standards again, we can 7 mixtures, including solutions, contain a combination of pure substances that can be separated, again, the separation techniques. And in this week's activity, we actually ask you to consider doing a separation task. So we've tried in this week's weekly materials to actually give you a lead into a range of activities where you can actually get your hands wet and get your hands dirty in some real trench science here by doing some of these investigations. And they're important things to do. At the Year 8 level, we can see properties of different states can be explained in terms of motion and arrangement of particles. Okay, a model for the structure of matter. Now we're getting into some more complex, more theoretical science. Particles in solid, liquids and gases, how are they different? And using the particle model to explain observed phenomena that link energy particles to temperature particles. So again, difference between elements, compounds and mixtures, chemical change, okay, substances reacting to new substances to form new substances. So we're looking at conversions, 225. So, we've unpacked this for you by year level so that the aim here is to help you structure assessment task B, part B, so that you can actually focus your misconception and you can focus your lesson sequence in the right place of the curriculum, under the right science understanding, at the right year level. So please consult this. And on the final page, a couple more belonging to Year 9. As you can see, in Year 9 and 10 become largely interchangeable, but we can see a lot about chemical reactions from atoms to form new substances, mass not being destroyed, mass being constant, density may shift but not mass, chemical reactions, look at combustion, reaction of acids, living and non-living systems, and energy transfer. So we're getting some really interesting experiments there. So have a close look at those when you're doing your assessment task. Make sure you're mapping your curriculum lesson sequences into the right year levels and targeting the right curriculum areas, okay, because they're the ones that fall within the jurisdiction of the chemical sciences model. I say that bearing in mind that assessment task number 1, part A, doesn't bind you, nor does part B. It doesn't bind you to the chemical and physical sciences. You're able to choose from across the science strands. Chemical sciences and sustainability is a big part of this week's focus. And sustainability, again, is one of the curriculum priorities of the ACS. And again, think about where you can find examples. And again, at the foundation year level, look no further than the environment, buildings and shelters. At the Year 2, materials, paper can be changed and remade or recycled into new products. At level 3, exploring changes from solid to liquid and liquid to solid can help us to recycle materials. It ties into the recycling theme. And the war on waste concept, that great video that we looked at in ABC Splash there, fabulous resource for exploring those two themes. Number 4, year level 4, considering the properties of materials can affect the management of waste, can lead to pollution, and describing how the products of combustion reactions affect the environment. So at year 9, so we can pluck any really year level of the curriculum, and we can actually map that year level for connections to sustainability. And again, we can talk about addressing curriculum priorities that way. The general capabilities, it's worth a mention, and we can see them down here on the right hand side of the page. They are literacy, numeracy, ICT capabilities. I recently got a shock here in Townsville to go into 2 quite large public state schools and discover, for instance, that there's only 2 computer labs across a school of 800 kids. And then they roughly get into the computer room once a term, which is a little bit scary. So again, we've got to look at the ICT capabilities. And again, for that reason, we need to think about mobile technologies, and using mobile phones and related tools. Critical and creative thinking. There's a big call at the moment to bring drawing back into the arts, back into the science framework. Dennis Goodman is a big part. Professor Dennis Goodman in Science by Doing, has his own little notebooking strategy. And the purpose of a notebook, of course, is to sketch and create. Sketch and create, to have critical analysis constantly theming throughout your thinking. Personal and social capability. Ethical understandings, intercultural understandings. If these terms don't mean anything to you, it is time to think about your generic and general capabilities. And the aim here is to develop the holistic learner, the successful learner, confident and creative individual, active and informed citizen. So it's harkening back very much to an Aristotelian view of the world, and it's the child, the student as a citizen of a science community. And they're across the entire Australian curriculum. And again, a lot of the lesson plans in Primary Connections and in Science by Doing map onto these general capabilities to make them explicit for you. It's something you may also want to address in your lesson sequence. Actually highlight which general capabilities you're targeting. The focus on investigations. This week we're asking you to do a few. Emulsion, which appears at the current year levels. Ice cream exercise, years 2 and 3 is a brilliant one. Crystals, year 7. Separation, year 7. And little pH examples with swimming pool, often as the focus, at year 9. And just a couple of caveats here. Many of you come into chemical sciences as an out-of-area teacher, and this is why we're saying to you, put on the teaching shoes, put on the chemical science shoes, try some of these applications, try some of these investigations, because just because you're an out-of-area teacher, it doesn't mean that you need to be a novice. You can colonise a part of this area that you actually really enjoy and know a lot about, and you can share that confidence with your learners in a way that transfers across the other areas of sciences and chemical sciences that they may look at. And so this week we ask you to do at least one investigation from the range we've provided, and also to try your Chemical Maze app. Okay, a little task there on your own personal products. Select 3, identify some of the chemicals within those, and do an analysis on the toxicity and how they break down in your body. You may get some interesting surprises. And finally, little concluding note, let's not overreact. The assessment task is due at the end of week 6. Let's clarify that. We have content up to the end of week 5, and then there's a week to polish that content, get some peer review happening, and get it submitted into the Moodle in plenty of time for the end of week 6 to enable us to get started with the marking. So please do look ahead, plan ahead. These are not really assessment tasks that can be done at the last minute, as you've probably realised. So do plan ahead, but don't overreact. There's a big difference. Please keep the questions coming. We're getting some very good ones. I appreciate them. And on that note, I look forward to seeing you all in the Zoom Collaborative next Wednesday.